In this video, we'll discuss volume. Now, volume is the amount of space a solid occupies. Like area and surface area, we can use the moving and additivity principles to help us with more complex solids. We also have Cavalier's principle to help us, and this states that if I look at two solid shapes that have the same cross-section throughout the entire solid and they are the same height, then they have to have the same volume. Now, where does this become helpful? If we look at oblique solids, so non-right solids. For example, if I look at these two cylinders, if I take cross sections, like take a slice out of each of those cylinders, they're always going to have the same circle because they have the same radius. Even though this one is slanted, they also have the same height. So even though it's a slanted shape, I could find the volume of a right cylinder, and because it has the same radius and same height, this slanted one will have the same volume. And if we think about it, if take a stack of quarters, say I had 10 quarters, whether I stack them perfectly or whether I zigzag them like this one zigzagged, I still have the same volume because it's still 10 quarters. So that's one way to help think about how Cavalier's principle works. Now, there are several formulas we have to know for volume, and they're all based upon the same general idea. We still have our common portions we need to know, such as the capital B means the area of the base, so the entire area. The lateral area is capital LA. The perimeter of the base will be the capital P. We still have to know the height of the solid, so that's the perpendicular height to the base, versus the slant height, or the lateral distance. So looking at one of the faces in its lateral distance to the top. Now, a prism or cylinder are always the volume of the area of the base times the height. So we have to recognize what is our base. With a cylinder, we often know that that's pi r squared because it's a circle. So we sometimes will say that one very specifically. Whereas a pyramid and a cone are common as well. It's 1/3 the area of the base times the height. However, a pyramid could be any shape, whereas a cone is a circle, so we know the area of the circle would have to be pi r squared. That's the only difference between pyramids and cones, and then between prisms and cylinders, is just we know that specific shape to be a circle. A sphere is 4/3 pi r cubed. So these are common formulas you should know and should memorize. So let's look at a few examples. A cylinder that has a diameter of 16 inches and a height of 20 inches, and we want to know what is its volume. So first thing I do is I draw out the actual picture. I have a diameter of 16 and a height of 20. Now if I think about the formula, it says it's the area of the base times the height. Well, we know that the area of the base is a circle, so we're looking at pi times the radius squared. Since our problem gives us the diameter, we have to remember that the diameter is 16, so the radius is half, or 8 inches. I plug in 8 inches, and I would end up with 64 pi square inches. So I'm going to take that 64 pi square inches and multiply it by 20 inches to get my entire volume. This would give me 1,280 pi cubic inches. Now say that I'm going to look at another example of a pyramid. The Great Pyramid of Giza has a square base of 756 feet and a lateral distance, which is the same thing as the slant height, of about 591.5 feet. And I don't know what's the volume of this Great Pyramid. So first thing I do is I label what I know. I do not know the height because the height's the perpendicular distance from the base to the tip. However, if I look at this image, what I do recognize, because that's perpendicular, is I can form a right triangle right here. So then I have to think about what information I have and how I can use it. I have that slant height, which would be the hypotenuse of the triangle. What I need to know is, well, what's this new dotted line? If I think about what I know about the pyramid and the fact of what type of triangle this is, I can recognize the height comes down to the center, which means that it's halfway between the two sides of my base. So if I take half of the length of one of the sides, I'll get that distance, which is 378 feet, because that's half of 756. Use Pythagorean theorem and find that height, and I'd find it's about 455 feet. Now I have the ability to do my volume. 1/3 the area of the square, because that's my base, times that perpendicular height to the base. So 756 length, 756 width, 455 height. And that will give me 86,682,960 cubic feet. Now here's a more complex problem. We use water tanks for cattle when we're trying to make sure they have water all day long. One of the common sizes for this is an oval shaped tank that is 4 feet long, 2 feet wide, and 2 feet high. So we want to know how many gallons could a tank like this hold. If we know that 1 cubic foot is about 7.5 gallons, and we often measure water in liquids in gallons. So first thing we need to do is figure out, well, how can we find the volume of the shape in cubic feet? We don't know the volume for a shape that has an oval. However, what we could do is split this into shapes we know. And if I think about what I have here, if I draw in these lines here, I would have a half cylinder, and a prism in the middle. Now that half cylinder, I'd have to recognize that the entire width would be like the diameter of that half cylinder. So if I want the radius, I'd have to do half of that. So 2 feet split in half would be 1 foot. So if I think about that top, it's 1 foot for this half cylinder, 1 foot for this half cylinder, which means that the prism width would have to be 2 feet. So now I can take my 3 separate volumes and find them to find the volume of this entire tank. So I have the half cylinder on the left, and the half cylinder on the right should be identical, so I can use this image to help me put it together. My prism in the middle should have a length of 2 feet, a width of 2 feet, and a height of 2 feet. So the 2 by 2 by 2. I find each of their individual volumes. So the volume of the half cylinder, that'd be half of a cylinder times pi times the radius squared times height, which would come out as pi cubic feet for each half cylinder. Find the volume of the prism, that'd be length times width times height, be 8 cubic feet. And then I can find the volume of the entire tank. 2 half cylinders plus the prism. So I'm wanting to double the half cylinder and then add the cubic feet from the prism, which would give me about 14 3/10 cubic feet. Now this again is in cubic feet, and I want to end up in gallons, so I have to use this conversion to help me. Since I know that there's 1 cubic foot and 7.5 gallons, I know that 14 3/10 cubic feet would give me approximately how many gallons I need. Use the proportion to cross multiply, and I would get that I would have about 107 1/4 gallons of water.